Okay, get ready for this. What if I told you the language we speak, the words coming out of my mouth right now, aren't flat? Today, we're diving into this absolutely wild idea where ancient mysticism crashes right into modern science, and it might just reveal a hidden geometry in the words we use every single day.
No, seriously, just think about that for a second. What if our words aren't just these flat strings of letters on a page? What if they're actually paths, like actual journeys being traced through some kind of complex hidden geometric shape?
And here's the crazy part. This idea isn't new at all. In fact, it's ancient. We're talking nearly 2,000 years ago. This mystical text, the Sefer Yetzirah, which means Book of Creation, it imagined the 22 letters of the Hebrew alphabet as the literal building blocks of the universe. And get this, they were arranged on the edges, faces, and axes of a cube. So for centuries, people just thought, okay, that's a beautiful metaphor, right? A cosmic cube. But what if it's actually more than that? What if it's real? Well, a brand new scientific model is taking that ancient idea, that cosmic cube, and it's asking a pretty profound question. Could this be the key to unlocking a deeper reality within language itself? But here's the thing. That one cube and its 22 letters, it's just the starting point. I mean, it's great for capturing the consonants. You could call it the skeleton of the language, but it totally misses all the nuance, right? The vowels, the timing, the rhythm, all the stuff that actually brings the words to life. And that's where this modern model comes in. It's from this fascinating field called topological linguistics, which is basically just the study of language's hidden shapes. And the solution they came up with? It's not just one cube. Oh no. It's 3 cubes, all nested inside each other, like Russian dolls. And together, they create this much, much richer 46-symbol alphabet. Okay, so how does this work? Well, it all starts with that original idea from the Sefer Yetzirah. You take the 22 base consonants of the Hebrew alphabet and you map them onto the big outer cube. We'll call it cube 0. You've got letters on the 12 edges, 7 on the faces, and then these 3 special mother letters sitting right on the central X, Y, and Z axes. This is our foundation.
Okay, next up, we need to add some nuance, right? So picture a second cube, cube 1, just floating inside the first one. Its 12 edges represent what the model calls the seconds. And these are your vowels and all those little markings, the diacritics, that help flesh out the language. And then we go even deeper. Right at the very core of it all, there's a third cube, cube 2. And this one holds the 12 secrets. Now, these aren't letters you'd ever write down. Nope, they are hidden operators, the things that govern the invisible rules of how we actually speak. So what you end up with is this really elegant layered system. You've got the outer cube for the consonants, the middle one for the vowels, and that inner cube for all the deep, hidden grammatical rules. And altogether, they create this amazing, comprehensive 46-symbol system. But what are these secrets really? Well, just think about all the things you do when you talk without even realizing it. Like how you shift the stress on a word, or you make one vowel just a little bit longer than another, or you take a tiny pause between phrases. Those are the secrets. They're the hidden operators, the invisible engine that's running the whole show when we speak. Okay, so we've built this beautiful geometric alphabet. Awesome. But how does it actually make words? I mean, what's the next step? This is where things get really, really cool and dynamic. Well, the system is called a loop walk grammar. And here's the key. A word isn't just a flat line of symbols anymore. Instead, I want you to imagine it as a walk. It's a path that literally moves from point to point across that outer cube. And then, boop, it hops inward to the other cubes to grab a vowel or apply one of those secret rules. It's a 3D journey. Let's make this concrete with a real example. Let's take the Hebrew word kadash, which means to make holy. So the path for this word would start on an edge of the outer cube for the ka sound. Then it travels over to another edge for the da sound. Then it moves to one of those central axes for the sha sound. And from there, it can hop inward to cube 1 to pick up a vowel, and maybe even deeper to cube 2 to apply a rule about timing or stress. You see? The word literally becomes a journey through this entire structure. Now, this is an incredibly elegant model, right? It's beautiful, but a good scientific model has to be more than just pretty. It has to be testable. So the million-dollar question is, how on earth do you test if language actually has a hidden geometry? Well, the research team proposes a really cool two-part test. First, there's the statistical test. The idea is to map over 50,000 Hebrew words into these 3D paths and see if they look any different from just random walks on the cube. Then there's the second part, which sounds like something out of science fiction, a physical demonstration. They want to use a dust chamber to prove that this layered code can actually be physically encoded in a real-world medium. How cool is that? So the core of that big statistical test is something called the topological efficiency hypothesis. And the idea behind it is actually beautifully simple. It's basically that the words we use all the time, the most common high-frequency words, should follow the path of least resistance. They ought to be the easiest, most efficient paths through the cube. Fewer turns, fewer costly jumps between the layers. Basically, they should take the shortest, straightest routes possible. And this leads to a very clear, very testable prediction. If you map real words onto this cube structure, their paths should have a much lower energy cost than just a bunch of random paths would. In other words, real language should look efficient and, well, ordered. It shouldn't look like chaos. Okay, let's just zoom out for a second and think about the big picture here. Because if this model actually holds up, it's so much more than just a clever puzzle. This could be a fundamentally new way of understanding the very structure of language itself. So, let's recap the key takeaways. First, language might not be flat at all. It could have this underlying hidden geometric structure. We've seen how a simple 22-letter alphabet can explode into a rich 46-symbol 3D code. And in this system, words aren't static. They're dynamic paths that journey through this structure. And maybe most importantly, this isn't just a what-if idea. It makes real, testable predictions for both linguistics and physics, which is just incredible. And even though this whole model was developed using Hebrew and it was inspired by that ancient Hebrew text, the principle behind it could be totally universal. I mean, it suggests that every language might have its own unique geometry, its own hidden shape that's secretly governing its structure and how it evolves over time. And that leaves us with a really fascinating question to chew on. If something as messy and human and organic as language can actually be described with geometry, what else out there is just waiting for us to discover its hidden shape? Think about it. From our own biology to our massive social networks, what other parts of our world will finally make sense once we find the right geometry to look at them?